Let's now take a look at example 7 in our section 4.4. So example 7 starts out with part A asking us to list 3 different antiderivatives of the function 4x cubed. So I'm going to go ahead and name one. What I'd like you to do is pause the video and see if you can name another. All right, now let's look together. Well, x to the 4, we can see that is an antiderivative because when we take the derivative, we get 4x cubed. But what if I had x to the 4th plus 7? When I took the derivative, what would I get here? I'd still have 3x to the 4th. Then the derivative of 7 is just 0. So I'd get the same result. So x to the 4th plus 7 is also an antiderivative of 4x cubed. What else could I put here? Could have x to the 4th plus 1. I could have x to the 4th minus pi. So what are some patterns that we're seeing here in these different antiderivatives? Well, we know that this piece of our antiderivative is really important. But then I can add whatever constant I want, and I will still have an antiderivative. So this leads us to an idea of the most general antiderivative of a function. So the most general antiderivative of this 4x cubed looks like x to the 4th plus c, where c is any constant. So to communicate that we can just add a constant and get another antiderivative, we write a general antiderivative as our kind of root function plus c, plus a constant. And this leads us to our final definition in section 4.4. So let's let f of x be an antiderivative of f of x. So any an antiderivative. If c is any constant, then the function f of x plus c is called the most general antiderivative of f of x. And we write how we notate this general antiderivative is the integral of f of x dx is equal to big F of x plus c. So notice, how is this integral that we meet here different than the definition of an integral that we saw in the previous section? Well, you might notice that we don't have any decoration here and here, or limits or bounds of that integral. So this is what's called an indefinite integral. And we see that in the last part of our notes. So there are 2 integrals that we have met so far, one we just met and one we met in the previous section. So we call a definite integral an integral where we have a bounds on our integral. So this means specifically we are looking for an area under a curve. This is an area under f of x from a to b. While this new notation we've just seen is called an indefinite integral. And the result of an indefinite integral is the most general antiderivative. So this indefinite integral represents the most general antiderivative of little f. So a couple other points here is this definite integral is going to be a number. So you're going to calculate a number, an area, while this indefinite integral is going to be a function, and it's going to include a c and a function with a constant, just like we saw in that definition of the box above of a most general antiderivative. All right, so let's just end quickly with some examples to compare these different ideas. So let's look at the integral of x to the fourth dx and compare that with the integral from 0 to 1 of x to the fourth dx. So this first integral is an indefinite integral. It's asking us to find the most general antiderivative of x to the fourth. So for us, we saw that in example 7 is going to be 4x. Oh, let's back up here actually. This is slightly different than the example we saw in 7. So in 7, we were looking for an antiderivative 4x cubed, and that antiderivative happened to be x to the fourth. But now we're looking for an antiderivative of x to the fourth. And that's okay. That's going to look similar. It's going to be x to the fifth over 5, using that power rule plus c. Here we go. All right, so how does that compare then to the integral from 0 to 1 of x to the fourth? Well, this definite integral is going to be a number. And yes, we want to use this antiderivative to help us compute that number. But how do we use it? We're going to write out that antiderivative, but now we need to evaluate it at 0 and 1 and take the difference. So that looks like 1 to the fifth over 5 minus 0 to the fifth over 5, which becomes 1/5 minus 0, which becomes 1/5, which is, as we might have guessed, a number. So again, here, definite integral, we're finding a definite number, a definite area under this curve. While here, an indefinite integral, we're just computing the most general antiderivative. All right, so we're going to do some more problems, get you more familiar with these different types of concepts and ideas. The more problems you do, the more comfortable you will feel with them. All right, thank you for watching all these videos. I know there were a lot to this section. Thank you for watching. Keep up the hard work.